All right, so in this lesson 7-3, we're looking at verifying trigonometric identities. All right, and so just to kind of give you an overview about it, when you're trying to verify the trigonometric identities, okay, it's almost like, and it really is pretty much doing a proof. So if you remember proofs that you did in geometry where you started with a statement and then you were asked to prove something, and through a series of steps, statements and reasons, each statement justified by a reason, you had to come up with what they were asking you to prove. And so verifying these trigonometric identities is kind of the same idea. It's almost like a proof. It's kind of like, I always describe it or compare it to like trying to put a puzzle together, right? And so here's kind of some guidelines that you can use. And so the first one, work with one side of the equation at a time. It's often better to work with the more complicated side first. So that's a guideline. Work with the complicated side first. Look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator, right? So basically anything that you can do to make it simpler is always, a good direction to go. Look for opportunities to use the identities, right? Note which functions are in the final expression that you want. Sines and cosines pair up well. So do secants and tangents, cosecants and cotangents, because there's a lot of identities that can change them back and forth into those different pairs. And so when you're trying to verify these identities, okay, you want to be familiar with all the identities that we had looked at the beginning of the unit, right? Because these are what you're going to use in order to get from what you start with to what it's equal to, okay? So we have to be really familiar with our identities. Also, here's an important part. Note which functions are in the final expression that you want, because you're going to be looking for ways to get those in there. Like, for example, if your identity that you're trying to verify has something equal to sine of x, then you want to be looking for ways to get the sine function in there, because you can never make it match until you get sine in there. All right? And so, let's see, what else? When the preceding guidelines don't help, just try converting all the terms to sines and cosines. All right? So try that. And then always try something, even making an attempt that leads to a dead end, provides some insight. And that is one of the things that can make these identities challenging, is there's so many different ways that you can go, but you want to go down a direction that gets you closer to verifying what they ask you to set it equal to, or ask you what it's equal to. You see what I mean? So you could be going a couple of steps down the wrong way, okay? And there may be times that you've got to back up and start over until you get going down the road that gets you closer to verifying the identity. Also, here's another thing I want you to make sure you make a note of. There is often more than one way to verify an identity, right? So there's not always just one correct answer. Sometimes there's several different ways that you can get there. And you'll kind of see what I'm talking about as we go through some of these examples. So here's the first identity that we are going to practice. Okay? So, again, what we want to do is we want to start, remember, with the more complicated side. So we're going to start with this side. So we want to turn this into this by following these guidelines. Okay? So we're going to start with this. Once we turn it into this, we are done. Okay? So that is our goal here. All right, so let's start with it. Let's see what we got here. So we'll start with secant squared of theta minus 1 over secant squared theta. Okay? All right. So I want to see what I can change this into that's going to get me closer to this. Okay? Now, anything that you can do and change to make stuff combine together, cancel out, all of those kinds of things, anything that will make it simpler, than it was before, is always a good way to go. So when I take a look at this, if I look at this secant squared, right? Okay, let's take a look at the identities that involve secant squared. Okay, so when I look at this one, I see that secant squared, okay, is equal to tangent squared plus 1. All right? Now, okay, so once you see that, okay, I can turn this into tangent squared plus 1, but the real question is that going to help me simplify something? The answer in this case is yes, because what do we have right behind this? We have a minus 1. So the plus 1 and the minus 1 are going to do what? Cancel each other out, disappear, make 0. All right, so that's actually going to be something that can simplify us a little bit. So I'm going to take secant squared, and I'm going to turn it into 1 plus tangent squared. Okay, so I'm going to take out secant squared. I'm going to turn it into tangent squared plus 1. All right, and what's behind that? Minus 1. And all this is still over secant squared of theta. Okay? These are gone, so my next step is going to be tangent squared of theta over secant squared, right, of theta. All right, so that's a little bit simpler than it was at the start, so that's a good step. Okay, now, here's the next thing that we want to try to start considering here. Okay, so again, we always want to get closer and closer to this, to sine squared. Okay, now, at this point, okay, I don't have any sine squareds here, but let's take a look. I've got tangent squared, and I've got secant squared. I've got tangent squared, and I've got secant squared. Okay, so one thing that I can do here, and you'll see why this is going to help here in a minute, because sometimes you just have to do the steps and then let them piece together. One thing that I can do next is I can take secant squared, right? Because remember, secant squared, if I'm looking at this one, 1 over secant squared is equal to cosine, right? So 1 over secant is equal to cosine, so 1 over secant squared is equal to cosine squared. So one thing that I can do kind of to get rid of my fraction here is change secant squared to, in the denominator, to cosine squared in the numerator. So tangent squared times cosine squared. All right. Now, here is the reason why we did that. So here's why we utilized this identity to turn secant into cosine. Because now I've got tangent squared here. Well, remember, what am I trying to show that it's equal to? I'm trying to show that it's equal to sine squared. So I can't get to where I'm trying to go until at least I get a sine in here, right? So now my next step needs to be to try to get sine into this thing somehow. Well, let's take a look at tangent. Well, what's tangent equal to? Tangent is equal to sine over cosine. All right, so that's one way that I can get my sine in there, right? And that actually is going to work out very nicely to have a sine squared in the denominator, because what do you have in the numerator? Or excuse me, not sine, cosine. It's going to be nice to have a cosine squared in the denominator because we have a cosine squared in the numerator, and they'll end up canceling out and leaving me with what I want. Okay? So now I'm going to change tangent squared, right, to sine squared over cosine squared. Okay? So that'll be sine squared over cosine squared times cosine squared. Okay? And then, of course, my cosine squared cancels out, and it leaves me with exactly what I'm trying to show, and that is that it's equal to sine squared, and then we're done. All right, so now, since you can see kind of the end result here of this, and the fact that we were trying to make this cosine squareds cancel out, okay, that kind of now shows you why it makes sense to turn 1 over secant squared into cosine squared, because we're trying to set up the next step of changing tangent squared into sine squared over cosine squared and making them cancel out. Now, if we had a little bit more time, then we would have thought the whole process out and say, okay, that's why we need to change this. But I just kind of told you to do it and then walked you through it to show you why it worked out. But like I say, if we had some more time, you would be able to think through it and say, okay, this is tangent squared. I can get sine in there, but what am I going to do with this cosine squared? Well, when you change it, they'll cancel out, and you'd be able to see that. You see what I mean? All right? So like I say, it's almost like trying to put a puzzle together, and you're trying to turn this into this using these strategies and these identities. All right? Now, remember what we said earlier. A lot of times there's more than one way to do each one of these, and that's the case on this one. Let me show you an alternate way of getting the same answer. So let's say we start off again with secant squared minus 1 over secant squared. Okay? Now, we can still show that it's equal to sine squared by going a little bit different route here. As a matter of fact, it involves splitting this up into two different fractions. So now I can have secant squared over secant squared. Okay? Minus 1 over secant squared. All right? And so, since these terms are the same, that actually divides out and makes 1. So at this point, now I've got 1 minus, and 1 over secant squared, we know we can change that. 1 over secant is equal to cosine, so 1 over secant squared is equal to cosine squared. All right. Now we're almost there because 1 minus cosine squared. Okay, look at this. So if I put, let me see here. Yeah, if I move this over here, if I move the cosine term here over to here, I have sine squared equals to 1 minus cosine squared. So what's 1 minus cosine squared equal to? Sine squared, and then we've got it. All right. So this is an alternate way of arriving at the same answer and verifying the identity. And as a matter of fact, it's shorter than the first way that we did it. So like I say, a lot of these identities are going to have multiple ways that you can go through and find the answer. All right. So the important thing is keep these guidelines in front of you. Even if you go down a road that doesn't work, then just backtrack and try a different route. And that is one of the things that can make this so challenging, is because there's so many different ways that you can go. You've got to make sure that you're going down a road that leads you to verifying the identity, that would lead you to this in the end. All right? And like I say, you may have to backtrack and start over a couple times on these. Okay? All right, so the next one. Let's see what we've got here. We're starting with tangent x plus cotangent of x. And we're trying to arrive at secant x, cosecant x. We're trying to show that these are equal. Okay. By the way, if you just picked a value for the angle, put this in, you would see that they are the same. So that's a way to make sure that you're satisfied in your own mind that they are equal. But now we actually have to verify it. All right. So let's think about some of the things that we can do here. Well, at this point, it's not really a whole lot we can do, but just kind of change these two into what they're equal to. So what's tangent equal to? We have two different options here with both of these. Okay, we can either turn them into what their reciprocal is, all right, with tangent and cotangent, but really all that's going to do is just kind of make the reciprocal of what you have here, and it won't allow anything to simplify or cancel out. Okay, but what we should rather do then is use the quotient identities. All right, so I'm going to turn tangent into this and cotangent into this. All right, so after that we would have sine of x over cosine of x. All right, that's what tangent's equal to, plus and cotangent is equal to cosine of x over sine of x. Okay? All right, so from here now, what we want to try to kind of attempt to do is see if we can create a common denominator so that we can add these fractions together now and make one fraction out of them. And so what would I need to do to make a common denominator? I need to multiply this fraction by sine of x and this fraction by cosine of x. So we'll multiply this one by sine and get sine squared of x over cosine x times the sine of x, okay, plus, and for this fraction, okay, we need to multiply the top and the bottom times cosine, so that then becomes cosine squared over sine of x times cosine of x, okay? All right, so where can we go from here? At this point, I have common denominators, so let's add the fractions together. Sine squared x plus cosine squared x over, let's see, cosine x sine x. So I've got my common denominator, and I have now created one fraction out of this. Now, here's how this helps me. Okay, remember they said a lot of times turning things into sine and cosine is beneficial because there are a lot of formulas that involve the sine and the cosine. So when I'm here looking at this now, what's sine squared plus cosine squared equal to? It's equal to 1. And so now I'm going to change that to 1 over cosine x times the sine of x. All right, so that gets me a little bit simpler. Okay, now take a look at what I'm trying to prove. Secant, cosecant. All right, well, what's 1 over cosine equal to? Secant. And what's 1 over sine equal to? Cosecant. So now we can see the end of the line here. I'm going to split these up, first of all, into, well, I don't even really have to do that, I guess. Let me see. Yeah, just to make sure we drive home the point that they're equal. So this will be cosine x times 1 over sine x. So I'm splitting them up just to emphasize the fact that this one is equal to secant. Oops. So this one is equal to secant. And this one is equal to cosecant. All right, and we have now verified the identity because we've gotten to what they had asked us to come to. All right, one more to practice. Hey, y'all have a good weekend. Okay, so we want to verify now that the cotangent of theta times the secant of theta times the cosecant squared of theta minus the cotangent to the third power of theta times the secant of theta is equal to cosecant. All right. So I need to see if I can come up with some kind of way now that I can show, whoops, and I don't need this here. So I need to turn this into just this somehow. Can we do it? All right, so let's see. All right, so from here now, what we can kind of work on in this particular space right here is, see, when we're looking at this expression, the cotangent to the third power, and my secant right here, okay, remember if we look at, let's see, if we want to look at, we want to look at, so you got to think through this one just a little bit to make sure that you're going down the right track. And so kind of what we're going to do here is we're going to, because remember, one of the guidelines is to see if you can have an opportunity to factor out an expression, and we do have that opportunity here. So let me kind of show you what I'm talking about. Okay, between these two, what are the common terms? Or in other words, what can I pull out of here? All right, the common factors. Well, I can pull out a cotangent, right? I can pull out a cotangent. Okay, we can pull out a cotangent, but we can also pull out a secant. All right. Oops. We can also pull out a secant. Okay. All right. Now, once we do that, what's left inside of the parentheses? If I pull a cotangent out of here, right, and a secant out of here, the only thing that's left in the parentheses is cosecant squared. Okay. Minus, so if I pull a cotangent out of here and a secant out of here, I'm just left with cotangent squared. Okay, so like I said, one of our guidelines is to factor expressions out if we can, and we can in this case. All right, so how does that, in essence, make it better for us? Look at the parentheses. Cosecant squared minus cotangent squared. Well, right here, if I move this over, cosecant squared minus cotangent squared is equal to 1, right? So now this entire expression is equal to 1. So what are we down to now? Cotangent times secant, all right? And so we're getting closer to what we want to turn this into. These two things can be turned into something here now. Look at this. Cotangent is equal to cosine over sine. Cosine over sine. Okay, cosine over sine. And secant is equal to 1 over cosine, which works out good. 1 over cosine, which works out good because now the cosines can cancel out and leave me with 1 over sine. And 1 over sine, guess what that's equal to? What I'm trying to prove or what I'm trying to verify? Cosecant. All right, and we're done. Okay, so like I say, on some of these, you really got to have to kind of think through the route that you're going to take to get from this to this. All right, and it's going to be a little bit easier on your quiz than doing this from start to finish, because what I have is I have like the steps on there and the blanks, and you just have to put the right step in the right blank. All right, so when it comes to your quiz, it'll be a little bit easier than just having to do the whole thing from start to finish. Okay?